Hello everyone, my name is Hirotaka. Today I would like to introduce our recent research study. The title of this presentation was Pathogenetic Mechanism of Four-Part Proximal Humeral Fracture. I have no financial relationships to disclose. Four-part proximal humeral fracture is frequently seen in the elder population. It is a comminuted fracture in which the proximal humerus splits into the four parts, including head, greater tuberosity, lesser tuberosity, and humeral shaft. It is well known that this type of fracture often requires endoprosthesis, such as reverse shoulder arthroplasty or hemiarthroplasty. This slide shows the typical displacement pattern of four-part fracture. As you can see, head fragment is placed toward the valgus direction, and the lesser and greater tuberosities displaced anterior and posterior directions respectively. Why does simple sideways falling cause such comminuted four-part fracture? It has been believed that fragility of humeral head or the traction force of calf tendons play important roles in the development of this fracture. However, its pathomechanism has not been fully clarified yet. So the purpose of the present study was to clarify the pathomechanism of four-part proximal humeral fracture due to sideways falling using three-dimensional finite element method. 10 patients with unilateral proximal humeral fracture were included in the present study. There were 2 males and 8 females, and their mean age was 72, range 59 to 85. CT DICOM data of contralateral healthy shoulder were imported to the software Mechanical Finder version 12, extended edition. To simulate simple sideways falling, a compressive force 500 Newton was applied on the lateral aspect of the distal part of humerus. In the present study, we hypothesized that calf tendon may constrain the humeral head rather than providing the tensile force. Based on this hypothesis, the insertion site of four calf tendon were completely constrained in the FE models. Nonlinear analysis for fracture prediction was performed. The compressive load 500 Newton was applied with 100 steps. The distribution of Draka-Praka equivalent stress was visualized. Then, both the tensile and compressive element failure was visualized, and its propagation pattern as well as displacement vectors were investigated. Results. In all 10 models, a high stress concentration was seen in the surgical neck. As for the failure pattern of elements, tensile failure was mostly seen in the surgical neck as well. On the other hand, compressive failure was seen around the anatomical neck. This slide shows the propagation of element failure. In 185 Newton, tensile failure began at the lateral aspect of surgical neck, whereas compressive failure appeared at the medial aspect of anatomical neck. In 190 Newton, tensile failure extended medially along the surgical neck, whereas compressive failure extended laterally along the anatomical neck. Then, element failure appeared around the bicipital groove. This slide shows displacement vectors of each element. As you can see, humeral head rotated toward valgus directions. On the other hand, both less and greater tuberosities displaced anterior and posterior directions respectively. Moreover, distal part of humeral shaft displaced medially. Discussion. In the present study, all 10 shoulders demonstrated similar stress distribution and the failure patterns. Common findings were: number 1, stress concentration were seen at the surgical neck. Number 2, propagation of element failure extended lateral side to medial side in the surgical neck. Element failure was also seen at the anatomical neck, which extended to the bicipital groove. Moreover, the results of the present study clearly indicated that the humeral head may displace towards the valgus direction, lesser and greater tuberosities may displace anterior and posterior direction respectively. We assume that such displacement patterns reflected well the clinical findings. There were several limitations in the present study. First, this was a single bone analysis. The model did not include surrounding bones such as scapula. Second, we simulated only simple sideways falling. Therefore, further studies including other types of falling with various arm positions using whole shoulder joint models would be necessary to clarify the true pathomechanism of forward fractures. In conclusions, four-part proximal humeral fractures were successfully recreated on the 3D FE models. Simple sideways falling can cause comminuted four-part proximal humeral fracture. Cuff tendons may act as constraint factors for greater and lesser tuberosities. Thank you very much for your kind attention.